to two projects. In this video, we are going to explain about the project that is CIRA, Cyber Intelligent Risk Assessment Methodology for Industrial Internet of Things based on machine learning. So before getting into the execution, first let us understand what is this project about. The Industrial Internet of Things, or we call it as IIoT, has changed the way industries work. Instead of machines and devices working in isolation, they are now connected and can share information with each other. This connectivity allows industries to make smarter decisions, spot problems early, and improve how things run. So, because of IIoT, factories, energy systems, healthcare, and transportation have become more efficient and flexible. It helps businesses save time and resources while improving productivity and overall performance. In short, IIoT makes industrial systems smarter and more responsive to the world around them. While IIoT brought many benefits, it also comes with risks. Because so many devices are connected and exchanging data, there are more opportunities for hackers to exploit weaknesses. Devices might have security gaps, communication channels may not be fully secure, and sometimes proper protections aren't in place. So these makes IoT systems vulnerable to attacks like ransomware, DDoS attacks, zero-day exploits, and man-in-the-middle attacks. Such attacks can cause serious problems. Data can be stolen, operations can be disrupted, money can be lost, and companies' reputation can take a hit. In short, the more concerned, that is, the more connected these systems are, the more important it becomes to protect them from cyber threats. So here, traditional methods that is, traditional cybersecurity methods often aren't enough to handle the size and complexity of the modern IoT networks. These networks have so many devices and connections that our old fashioned security approaches can miss potential risks. Because of this, it is essential to use smarter, proactive methods that can identify and reduce cyber threats before they cause problems. This helps to make sure that data is stays safe, industrial operations continue smoothly, and the entire system remains secure even as it becomes more complex and connected. So to overcome with all such issues, the system we are developing it acts as an intelligent security evaluator for industrial IIoT devices that is designed to detect and address potential cyber threats before they can impact operations. Its main goal is to keep IIoT networks secure, reliable, and running smoothly. And it works by simulating variety of IIoT devices and examining key features such as device vulnerabilities, whether the device are up to date with security patches, the strength of authentication methods, their exposure to the network, and how easily they could be exploited. Each device is then assigned a risk score, which is categorized as very low to very high. These scores help the stakeholders quickly understand which devices are most at the risk and prioritizes security measures accordingly. By providing a clear, organized view of potential threats, the platform enables better decision making and proactive protection of industrial systems against cyber attacks. So the system uses several advanced machine learning approaches that are MLP, random forest, XGBoost, light GBM, decision tree, logistic regression, KNN, support vector machine to analyze IIoT device data and predict potential risks. It also simulates federated learning, which allows models to be trained across multiple devices or locations without sharing sensitive data. So here, to make the system results easy to understand, the platform shows visual summaries and risk ranking, confusion matrix, ROC, AUC curve graphs, and bar charts. Those visualizations help stakeholders quickly see which devices are at high risk and makes informed decision about prioritizing security measures. So here we will be evaluating all the models using accuracy, precision, recall, and FN score. And to further improve the performance of this project, here we have made several enhancements. So first comes hybrid ensemble model. It's a combination of different machine learning models that is used to analyze the data along with techniques that reduce unnecessary or less important features. This helps the system to make more accurate and reliable predictions. Then comes explainable AI model. So tools like Lime and Sharp are added to show which features are most important in influencing the predictions. This makes it easier for users to understand why the system gives certain results. And then, showing the factors behind each prediction, the system allows us to see informed decisions with confidence instead of treating a model as black box. And this is achieved by using these models, that is Lime and SHAP. And here we have developed a simple web interface by using Flash framework. So a web-based platform is developed using Flash framework and users can securely log in, provide input data and get predictions from the trained model without needing to interact with the complex backend process. And now moving on to the implementation. To implement this project here, we have followed the steps which are mentioned in the flow of work. So let's understand them. First, we have imported all the necessary libraries and the tools that are important for data handling, machine learning, and visualization. Then comes data acquisition. So at this stage, the system uses Keras dataset as input. Synthetic data is generated to augment the dataset and make the model more robust. And the dataset is then loaded into Pandas data frame for easy manipulation and analysis. Then comes data pre-processing. So at this stage, missing values are handled by either removing them or filling them with appropriate values. And categorical variables are converted into a numerical format for the models to understand. And numeric features are standardized so that all variables are on similar scale, improving model performance. Then comes data visualization. So the data set is explored visually to understand which features, that is, feature distributions, correlations, and different risk levels of the devices. And we split the data into train and test sets. So at this stage, the data is divided into training and testing sets to evaluate the model performance. For federated learning simulation, the data set is further split among the multiple simulated clients. Then comes model training. So at this stage, machine learning models are trained on pre-processed data to learn patterns and predict device risks. And all the models are evaluated using these metrics. Then comes confusion matrix. So this confusion matrix helps to visualize correct and incorrect predictions. ROC curves provide insights into the model's ability to distinguish between risk levels. And as an extension, we have incorporated this explainable AI part. So this is used to show which features most influence the predictions, making the system transparent. And best performing model will be saved for the future use. Then comes web application part. So at this stage, a simple input form allows users to enter device features. So the saved model is loaded, user inputs are pre-processed, predictions are made for the device risk, and the results are returned to the user. So here we have developed a Flash-based web interface where users will be able to give the input that will be pre-processed and it will be fed to the saved trained model and that will be giving us the result. And moving on to the algorithms used, these are the classical machine learning models that we have used. And here are the federated machine learning models that are support vector machine, XGBoost, voting classifier. And here we have extension model that is voting classifier. And here to implement this project, basically we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and hard disk of 25 GB and above. In software are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. These are the source code files of this project. Let's understand them. So this is the model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. Here we have static folder in which we have CSS, JavaScript and Bootstrap files which are important for the project's visual appeal. And here we have templates folder. So this folder we have HTML pages which are used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases folder in which we have test cases. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Here we have notebook file, which is a Jupyter notebook file, and it contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have the data set. So this is the data set that we have used in this project. Let's open it. So here we have the data set. So here we have multiple parameters. So based on these parameters only, we will be predicting the attack type, whether it is high level of attack, very low level of attack, medium level, or very high. So this is the data set that we will be using for models to train and simulate. Now close this. And here we have signup.db file, which stores the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I have copied it. Now open Anaconda prompt. It is open. Now give the command cd, give the space and paste the copied path. Click on enter. Here, if you observe, current directory is changed to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port. So this is the localhost and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Chrome, so I will paste it in that. So paste the link here and now click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Now we need to create an account. So click on create your account and enter all the details to create an account. I have already created, so I'll directly sign in, that is login. Click on login now and provide your username and the password, which are your credentials. So I'm giving my username and the password. Now click on access. Here you can see we are redirected to prediction page of the project, and here we have multiple parameters that are need to be given as input for predicting whether is high, low, or very low. So let's understand what are these parameters first. Device model. It is a specific model of the IIoT or network device. For example, Cisco 809 ISR, which helps to identify its features and vulnerabilities. Then we have device type. It is the category or the type of device often matching the model, indicating its function in the network. Then we have vulnerability score. It is a numerical value that reflects how susceptible the device is to the cyber attacks based on known weaknesses. Then we have attack frequency. This is how often the device has been targeted or it is likely to be targeted by attacks. Then we have patch status. It indicates whether the device software is updated or outdated. Devices are more vulnerable. And then here we have data sensitivity. It is a rating of how critical is sensitive the data handled by the device, where 1 is low and 5 is highly sensitive. And here we have network exposure. So it shows how exposed the device is to the external networks or the internet, with higher values meaning greater exposure. And here we have anomaly score. It measures unusual activity on the device. High scores indicate more abnormal or suspicious behavior. Then we have authentication strength. It describes the security of the device logins or access controls, for example, weak, medium, strong. And here we have encryption enabled. So it indicates whether the device encrypts its communications to protect the data. And here we have explainability. It shows how easily an attacker could exploit the device vulnerabilities. High scores means easier exploitation. And here we have device risk factor. It is a combined score reflecting the overall risk level of the device, considering vulnerabilities, exposure, and the other factors. Here we have impact. This represents the potential consequences to the operations, data, or systems if the device is compromised. Higher values can indicate more severe impact. So this is all about the parameters. Now let's enter them. So open test cases. So let's open test cases. Open this file. So this column we will be predicting. So we will be not giving as input this column. So let's apply filter to high class and let's see whether the application will correctly predict it or not. So let's check with this case where device model is Cisco 809 ISR. Here it is correct. And here device type is Raspberry. And here we have vulnerability score that is 3.8331. So paste it here. And attack frequency is 3. Patch status, it is unpatched. Data sensitivity is 5. Network exposure 0.188. And here anomaly score 94, and authentication it is medium. Encryption enabled, so here you can see encryption enabled is yes, and exploitability is 7.83. Device risk factor it is 9.07, and impact is 9.34. Now click on classify device risk. So this information, it will be pre-processed at the backend, it will be fed to the train model, and then that train model will be giving us a prediction. So here we have prediction it as high. So here you can observe application is correctly predicting that the data which contains these values, that means the system, that the device which contains these transactional values will have high risk. And this is the model confidence score. And here we have risk analysis. So here we have high risk analysis, immediate action is required, multiple unpatched vulnerabilities have been detected, weak authentication mechanisms, high network exposure, and frequent attack attempts has been detected. And these are the recommendations. Emergency response, we have isolate device, we have security, overall we have. And here we have risk probability distribution. So here if you observe for high case, that is high risk, we have 86% of probability. So that is why application is detecting the data to be high risk. That is the device to be at high risk. And here we have very low confidence score for all other categories. Now let's click on new assessment and check with the other class, that is low class. Apply filter to it, click on OK, and let's check with this case. So device model is IR rep, and here we have device type, that is RH, which starts with RH632 sensor, and vulnerability score is 1.88155, and attack frequency is 1, so give it 1. Patch status it is up to date. Data sensitivity it is 3. And then we have network exposure. So network exposure is 0.48. Anomaly score is 29.9. Authentication is weak. So here you can see authentication is weak. And encryption is no. Exploitability is 0.50. Device risk factor is 7.09. And impact is 6.36. Click on classify device risk. So here you can see device risk level is low, and here we have the CIRA assessment result, that is 99%. And here you can see good security posture, so minor improvements recommended, that is minor vulnerabilities present, more security controls, some outdated components, limited network exposure. So here you can see limited network exposure, some outdated components, moderate. So if you change these, it will show with no risk. And here we have recommendations. So these are the recommendations, that is to update patches. And here we have to strengthen the authentication. And here we have risk level probability distribution. So here you can see 99.9% confidence is for low. So that is why the application is predicting it is to be low. And here we have the other values. Now let's check with the other assessment. So let's apply filter to class medium. Click on OK. And let's check with this case, where device level is wind. So where do we have wind? Yeah, here we have wind sensor. And here we have device type, it is Cisco IR. And here we have vulnerability score, that is 9.29. Paste it. And attack frequency is 3. Patch status is outdated. Data sensitivity it is 1. Network exposure is 0.05. Anomaly score is 29.51. And the authentication is strong. So let's give it a strong. And here we have encryption enabled. That is yes, encryption is enabled, and exploitability is 5.33. Device risk is 3.917, and impact is 9.33. Now click on classify device risk. So here you can see medium level of risk has been assessed, and this is the model confidence, that is 99.7. And here you can see moderate risk level analysis. So here mixed security controls are there, some unpatched vulnerabilities are there, modern network exposure is there, and authentication weaknesses detected. And here you can see recommendations for Medium level of risk, that is immediate patching, network segmentation has to be done, enhanced monitoring has to be done. And here we have risk level probability distribution. Now click on new assessment. Let's check with the very high one. So apply filter to it, click on OK, and let's check with this case. So here device model is Emporia view. Device type is solar sensor. Vulnerability score is 5.11. So apply, paste it here. And then attack frequency is 3. Patched status is up to date. And here we have device sensitivity is 1. Network exposure is 0.97. And anomaly it is 52.64. Authentication strength is strong. So here you can see authentication strength that is strong. Encryption enabled is yes. And exploitability is 8.01. Device risk factor is 9.05 and impact is 9.58. Click on classify device risk. So here you can see risk level is very high. You can observe risk level is very high. You can see application is correctly predicting the risk level. And here we have model confidence that is 98.9% and critical risk level. So here severe security vulnerabilities have been detected, no encryption enabled, maximum network exposure and critical exploitability. And these are the recommendations, that is critical action required, emergency security team is needed, complete replacement should be done. And here we have risk level probability. So here you can see very high risk has been detected and 1.1% is assigned for high. So that is why major of the probability score, that is probability distribution, is given to very high. So that is why application is predicting to be very high. Now let's check with the other assessment. So let's try with the very low case. Let's check with this case where device model is wind sensor. Device type is energy and building control unit. Vulnerability score is 0.716. Attack frequency is 1. And patch status is unpatched. Data sensitivity is 4. Network exposure is 0.884. And anomaly is 48.16. And authentication strength is strong. Encryption enabled, we have yes. And exploitability is 4.3. Device risk is 8.3 and impact is 1.46. Let's click on classify device risk. So here you can see application is correctly predicting it to be very low. And this is the model confidence that we have. And risk analysis says that excellent security posture, your device demonstrates strong security characteristics. So these are the strong security characteristics. And here we have recommendations, maintain current security and regular audits are needed. And here we have risk level probability distribution. Now let's view the analytics. That is, let's view the graphs of this project. So click on view analytics. So here we have sample outcome graph. Here on x-axis, we have all the model names. I mean, all the targets that we are predicting. And on y-axis, we have count. So these are the various risk levels that we are predicting. Close it. And here we have heat map. So this shows the correlation between independent features. And here we have confusion matrix. Here on x-axis, we have predicted class and on y-axis, we have true class. And this diagonal represents the accurate predictions and the values above the diagonal and below the diagonal are the misinterpretations. Let's close this. And here we have RSC curve graph. This is the RSC curve graph. Close it. And here we have accuracy comparison graph. So here on x-axis, we have all the machine learning models that we have trained and on y-axis, we have accuracy. Close this. Precision score. Here we have the precision score. Recall score. F1 score. Here we have F1 score. FAR by the model, that is here on x-axis we have all the machine learning models and on y-axis we have FAR and here we have training time. So here on x-axis we have all the models and on y-axis we have the training time of each model. Close it. And here we have XAI SHAP explainability graph which shows the importance of each variable. So here different colors indicate different level of importance. So the values which contain these colors, I mean this color, it represents high level of importance, and this color represents low level of importance. Close it. And here we have XAI water plot. So here we have XAI water plot. Now close this. Click on logout. In this page, just by giving required parameters to the application, it will be correctly detecting the IoT's risk level. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.